Hello everyone, this is my Module 2 practice, and I will be going over my erosion bottles, and we were answering the question, what is the best land cover for a healthy watershed? I chose the standard from Earth Systems, processes that shape the Earth from the Next Generation Science Standards, make observations and or measurements to provide evidence of the effects of weathering or the rate of erosion by water, ice, wind, or vegetation. And I got that from nextgenscience.org. So first we started off by asking what is the best land cover for a healthy watershed? So that was the question that we were presented with, and we really had to think about and find a solution to. So I started off the engineering and design process with developing possible solutions, thinking about possible tools I might want to use, and previewing the erosion bottle experiment that was online for us to browse through. So I thought about the materials I would need, and I gathered up my things. And then my next stage in the engineering and design process was to make my prototype, start my plan. And I began by cutting apart three 1-gallon jugs to hold 3 different types of ground cover. So here's where I was developing and using my models, which came from science and engineering in STEM practices, because for science I was exploring a natural phenomenon, and then in engineering I was trying to solve how to stop erosion. The next step was to trim some of these smaller water bottles that I had to catch the runoff to see which water stayed the cleanest or the healthiest. I then added holes to the sides so that I could attach strings so that they could hang from the 1-gallon jugs. And then I attached the string, I just tied them through so they could loop over the end of the jugs. So I'm still developing and using my models. And in science, that was to construct the models, to create a simulation, and to explain erosion. And for engineering, that was to test my possible solutions, which would be what type of ground cover would indeed give us the healthiest water. The next step in my engineering and design process was create. So here's where I was testing and evaluating my erosion bottles. The first one that you see right here is the one that has soil and some mulch material, sticks, leaves. Here is plain soil. The area I live in has a pretty dry, medium infiltration soil, and then beside that I have just some grass and some ground cover. Okay, and here I was planning and carrying out my investigations. Science, I was doing that to answer questions, and I also determined my variables. And in engineering, I was testing my solution and deciding what impacts erosion. Next, for my results, I came up with, as you can see here, the cleanest, the water that stayed the healthiest was the water with the grass and some of the ground cover. The second best was the soil with, was mulch in there. It was a little muddy, not too bad. There was some debris that came through. And then the worst was just the soil alone. There was a lot of debris, small rocks, mud that traveled down into the water. So this STEM practice would be to analyze and interpret my data, and also obtain, evaluate, and communicate my information. And my findings were that the ground cover that leads to the healthiest water would be the grass, where there's a lot of vegetation as it holds the soil in place. So that is how I use the engineering and design process to answer my question for Module 2 practice.